So we have talked about a lot of things on matrices. Here we will discuss a very important topic, that is called as to find out rank of a matrix. Now the first and the most important question comes out to be, why are we finding out the rank? What is the need of finding out the rank of a matrix? Now the matrix, and further we will be also discussing about something called as eigenvalues and eigenvectors in this particular chapter, right? So rank of a matrix, let us first talk about what is the definition. When you go to the corporate systems, when you see the practical systems, this rank becomes very important for us. And these are system parameters known as eigenvectors and eigenvalues, which are system parameters. So those are very important for us to determine the performance of a system. Based on the values of eigenvectors and eigenvalues, we can determine the system, and we can form a synonymous systems. For example, these are system parameters. For example, if I say the eigenvalues are 3, 5 and 6, so those eigenvalues can be replicated to another system which to give the same performance. For example, on the basis of eigenvalues I can determine a system basically, right? So rank is very important from that perspective also. So let us go to the definition of what is rank saying. What is the definition of rank? Now, definition, if you talk about, the rank is nothing but the largest positive integer r such that a matrix has at least one zero, one non-zero minor of order r. Now, let me first put it down and then we will discuss what is this. You can say that rank of a matrix A is defined as the highest positive integer r such that the matrix A has at least one non-zero minor. Minor we have already discussed earlier. Minor of order r. Now, in a very simple language, this is definition. It seems a bit complex to you right now, but I'll make it very simple for you to understand what is a rank of a matrix. Basically, let's say there is a matrix A which is of the format 1 2 3 4, right? Now there are many cofactors, many minors you can find out, not cofactors. Cofactor has nothing to do with the rank, but many minors which we can form out of it. For example, there is one minor m11 is nothing but 4. There is m12 is 3, m21 is 2, and m22 is 1, right? Now what he's trying to say is that if you can find at least one, you can find at least one minor which is non-zero of the order r, right, then that will become your rank. Now you can find at least one. There is one non-zero minor available to this matrix. Yes, in fact we have 4 non-zero minors. You just want only one. Then the rank for this matrix is 1. Getting my point, right? Now you find out the determinant of, see, this matrix is something like 1 2 3 4. Now you find out the determinant of this. You find out the determinant of this, right? That is 4 minus 6. that is not 0. So the rank, if it is not 0, sorry, if the determinant is not 0, that means there is a rank which is equal to 2. Getting my point? Now supposedly if I modify this a bit, what I mean to say is, let's say I make a matrix, of, let's say, of the kind 3 2 6 4, let's say, right? Now what is the determinant of this? Highest order determinant what you can find is second order. You can form this 3 2 6 4. Now if I find the determinant of this, it comes out to be 0. So the rank cannot be 2. Let us go down, because you find that the largest positive integer r has not got a non-zero determinant. Okay, so here you have got a 0, so that is not the rank. Now if you go to the minors, so you have m11, that is 4, so that is not equal to 0. So your rank in this case will become 1. Clear? Right? Let us take another example. Right? I'll take a example which will make it very very clear that how you can form that particular thing. Right? Okay. Before going to that example, let us also talk about certain properties of rank. Right? Uh, let's say, let's go to the properties of rank. I'll take a fresh page for that. Let us put the heading properties of rank. The first property of rank says that for a matrix of order m cross n, the rank r is nothing but less than or equal to the minimum of m comma n. It's quite understood, you know. The rank cannot be, see, rank will be determined only by the square determinants, right? So even if it is a 4 cross 2 matrix of 4 cross 2, the maximum rank can be 2, can be 1 also, right? But it cannot be 3. Get my point? Because the maximum determinant which you can form, a square determinant you can form, will only be 2 cross 2. Clear? So you cannot have a rank of 3 in that case, right? We'll solve questions based on this, but let's understand this particular thing. Now, for a null matrix, let's say, for a null matrix is matrix containing only 0. Rank is how much? Rank is 0. Rank is equal to 0, right? Because there you don't have any matrix can be formed on that front, right? One more definition of matrix, I'll put it in the properties of matrix, is that rank can also be defined as, rank is the number of non-zero rows. Rank is nothing but the number of non-zero rows in a matrix, right? For example, if I say there is a matrix, let's say 1 2 3 8 1 7 0 0 0. So what is the rank? You can say, you can, this is a 3 cross 3 matrix, right? So rank is definitely equal to 2, because we don't have a third order determinant which is equal to not equal to 0, right? You cannot form a 3 cross 3 determinant which is not equal to 0. It will always be 0. So we have to go to rank, and there is a minor or there is a determinant of 2 cross 2. Let's say any of the determinant 1, 2, 8, 1. This is not 0. So that rank is 2, right? So this is how you can determine the rank, and you can say this is a property. Rank is the number of non-zero rows. So I can directly say that number of non-zero rows here we have seen is 1 and 2. That is why the rank would directly be 2, right? Another property you can say is for a non-singular matrix, its rank is equal to its order. Its rank is equal to its order, right? Very clear. It's quite evident with the definition of singular matrix. You can always say that, right? Okay. Now let us take one example so that it becomes very evident for us to understand. This question which I'm solving now came in GATE 2003. So let us discuss this question. There is a question which came in GATE 2003, right? The question given was, there's a matrix A. The values were 4, 2, 1, 3, 6, 3, 4, 7, 2, 1, 0, 1. Now, if you see the practical implementation, this is what kind of a matrix? 4 cross 3, right? This is 4 cross 3. And you have to find the rank. Your options were something like 4, 3, 2, and 1, right? Okay, can you tell me that what is the for a non-null matrix? For a non-null matrix, what is the minimum rank which is possible? 1. See, rank 1 will always be there if it is not a null matrix. Getting my point? At least one element will make that as a rank, isn't it? So you can always keep it a point. The property number 2 or 3, whatever we wrote, that for null matrix the rank will be 0, and you can also say that only for null matrix the rank will be 0. Otherwise the rank has to be 1 minimum. Okay. So here what can be the maximum rank? Can it be 4? No, it can be only 3, because you can form 3 cross 3 is the maximum possible minor you can form, or the determinant you can form. And how many you can form? You can form actually 4, right? What are those 4 you can form? Number 1, you can form a matrix or a determinant of 3 cross 3 in this fashion. You can say it can be 4, 2, 1, 6, 3, 4, 2, 1, 0. Now if determinant is not equal to 0, if this determinant does not comes out to be 0, I can definitely say the rank is 3, right? You just want the determinant, highest order determinant which is not equal to 0 will become your rank, isn't it? So if this is becoming not equal to 0, the rank is 3, right? I need not to go ahead, but if I solve this is coming out to be 0. So I have to check whether I can form another 3 cross 3 determinant or not. So the moment I get a 3 cross 3 equal to not 0, that's my rank. Otherwise I will have to move out to a smaller determinant. So next I can take is 2, 1, 3, 3, 4, 7, 1, 0, 1. Now unfortunately when I'm solving this is also giving me 0. So again I have got a 0. Let us look at the any other determinant which we can form of 3 cross 3. Yes, you can form a determinant of 3 cross 3 in the form 4, 1, 3, 6, 4, 7 and 2, 0, 1, right? you solve this is also 0, and the fourth determinant you can form is 4 2 3 6 3 7 2 1 1, and unfortunately this is also 0. So any other 3 cross 3 you can form? No. So I have not found a single 3 cross 3 minor, or you can say determinant, which is equal to non-zero. So you can say that rank is definitely not 3. Rank was definitely not 4. So rank can be 2 now. Let us check any of the 2 cross 2. Now here you can certify that rank is not equal to 3, because any minor was not equal to 0, right? All are equal to 0. So you wanted actually that any one minor should be not equal to 0. So rank is not 3. So let us check it with 2 cross 2 minor. Any minor, if I take, let's say I take the first one, 2 4 2 6 3, let's say, is it equal to 0? 12 minus 12, yes, this is equal to 0. Let us check with another minor. You can form many minors by this, right? This is 4 cross 3 matrix, so you can form many minors. Let us say the next one I will take 2 1 3 4. Now this is not equal to 0. This is 8 minus 5, that is 3. Sorry, 8 minus 3, that is 5. So this is not equal to 0. Any one, if it is not equal to 0, I can say the rank becomes, getting my point? If I have to check with any other thing, if I have to check all these 2's, 2 cross 2 minus become 0, all these 2 cross 2 minus become 0, then definitely I can say the rank is 1, right? So this was a type of question which was asked in 2003. So answer would be rank is 2, right? Option number 3. Clear? Right? Let us solve one more question from 2006 gate paper. Let us understand what was the question like. Question of 2006. This is gate 2006. The question was something like, find the rank of matrix. See, in this matrix, what are these numbers, these values which I am giving are some system parameters, right? These are connected to x, y, and z. You know, you can say this is coefficient of x, this is coefficient of y, and coefficient of z in the first equation. This is coefficient of x, this is coefficient of y, and this is coefficient of z in the second equation, and this is coefficient of x, coefficient of y, and coefficient of z in the third equation. And what are these x, y, z? You can say these x, y, z are some parameters. For example, temperature, pressure, volume, time, distance, whatever. So how these systems are defined in physical world, it is very difficult to analyze this thing. What is the need of mathematics? I have discussed this earlier also. Engineering mathematics is important because it is very easy for us to understand things in mathematical format rather than understanding the things in physical format. So this is very important for us to understand, right? So matrix is nothing but defining a system. If I change this value, x, y, z are going to be same, but the coefficients are going to be changed. So coefficients change, that means systems performance will change. So systems is defined based on this particular matrix, and we are analyzing this matrix. We're finding out the rank, the system parameters, which are the eigenvalues and eigenvectors, which we'll study in the later stages. Okay, so once you go to the industry, you will understand what are the practical implementation. In fact, there are softwares to do those things, but it becomes very easy for you to understand how the software is performing, because you know the internal. And that is the difference between an engineer and a layman who do not understand what is happening inside. Inside a machine, what is he says it is if you switch on the button, it will give you the xyz output, but how it is doing it is being understood only by an engineer, right? Okay, so let us come back to our question. You have to find the rank of this matrix, right? So if you observe this question, you can see that the row 1 and the row 3 are almost the same. Can I apply a elementary performance here? Can I say that R3 is nothing but R3 minus R1? Can I do that? Or uh, other way around, whatever you feel like. It's R3 tends to R3 minus R1. So the matrix will become how? The matrix will look like something this. R1 is not getting changed, R2 is not getting changed. You can definitely say R3 gets changed to 0 0 0. Any other row transformation, and can you make any other row 0? No, you won't be able to do it. Now we have a property which says the number of non-zero rows will give the rank. So how many non-zero rows we have? 2. This will give you the rank, right? And in fact you can check it out. If you find out the minor of 3 cross 3, it will be 0. And there is only one minor of 3 cross 3. If you find out any minor of 2 cross 2, 1 1, let's say 1 minus 1, right? You take this. So this is not equal to 0, and you can definitely say the rank is 2. Clear? So this was a question in 2006 of GATE, right? Let us take another example which came in GATE examination about the rank of a matrix, so that we'll understand rank in a very detailed thing, because many of the papers ask very simple questions on rank. So if you can understand this, you will be able to get the answer very easily. Let's say a very simple question. Let me put it forward for you. You have to find the rank of the matrix A. Let's say 1 1 1 1 1 1 1. This dot 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 means that this is going on, right? 1, and this is an n cross n matrix. Find rank. Right? Options, let's say we'll take is 0 1 n n minus 1. Now by observation, if you'll see, this is n cross n matrix. First method is put the n value of n, whenever we have solving an option based paper. But if you see, observe this keenly, all the elements are same. If you apply a row transformations, can we reduce this to only a single row of ones? Isn't it? You say R2 tends to R2 minus R1, R3 tends to R3 minus R1, R4 tends to R4 minus R1, and all the rows will ultimately become 0. So this matrix can be reduced to 1 1 1 1 1 1 1 1 1 up to n times, and the rest could become 0. Right? So ultimately, how many non-zero rows we are getting? I said the rank is nothing but a number of non-zero rows. So number of non-zero rows is equal to 1. So the rank is also equal to 1. That's your answer. Clear? So this is how you can easily solve question based on this particular fundamental, right?